Okay, so we're gonna start. We're gonna start off 4.4 with a warm up. Okay. So far, the first half of this chapter has been all about solving equations. Okay, so what we're gonna do now, it's gonna be pretty much the same thing, but there's gonna be an extra step involved. All right. So not only are we going to solve an equation, but we're gonna need to learn how to write equations also. Okay, and whenever we're writing equations, it's usually coming from some kind of a word problem. Okay, some kind of a story context or some kind of like a real world situation. Okay, so let's imagine here that, for your birthday party, okay, you want to rent out Pizza Plus. Okay, or whatever restaurant you like, it doesn't matter. Okay, so you're renting out some restaurant or whatever, arcade, whatever you want, okay, for a birthday party. So there's going to be some costs involved, okay? So we're going to say here that it's $100, okay, to rent it out, plus it's going to be $6 per person that shows up. Okay, and they get to eat whatever they want. Go get as much pizza as you want. Basically like a buffet. Drinks, unlimited refills, whatever. So $100 total, and then it's $6 extra for each person. Okay, these prices are just made up. So I don't know how much it is to rent out Pizza Plus. Alright, so when you finish here, okay, your total bill, we're going to say comes out to $262. All right, so that the question is, how many people came? How many people showed up? All right, so what we're going to need to do to solve this, first we're going to need to, whoa, can't you see that? Okay, so we're going to have to write an equation, and then we're just going to have to solve the equation for x. Okay, so whenever you're writing an equation, whenever you're trying to solve these word problems, okay, we're going to work on these a lot this year. Okay, the thing that you're looking for, which obviously that's important to know what you're looking for, okay, but the thing that you're looking for, that's x. Okay, so x in this case, for this equation, okay, represents the amount of people that are coming to your party. Okay, sure, you might have invited, 25 people, 40 people, whatever, but maybe not all of them showed up, okay? Maybe some of them said they did, trying to be sneaky and didn't show up. See if you're going to notice. All right, so we're trying to see how many people showed up. So that's going to be x. All right, now, if you think about the equation, the part, or the problem, the word problem, the part that deals with people, or a person, is the $6 each. Right, so it's going to be $6 for each person. So that's going to be a 6x. All right, and then remember, it's plus, in addition to $100 just flat amount to rent it. So it's $100 plus 6x. All right, and then the total bill is going to be $262. So our equation, what our equation should look like here, and you can switch. It might look a little different for you. 100 plus 6x equals 262. And so if you think about it, this is like, I always talk about mathlish in English. That's all we're doing. That's all word problems are. You're just trying to translate the English and the problem to mathlish. Okay, usually we're going backwards. So you can see here, $100 flat plus $6 per person. Remember, an x is the people, because we don't know how many it's going to be. That's what we're looking for. All right, and then the total, okay, obviously is means equal. Total's 262. All right, so you should subtract 100 and then divide by 6, and that would tell you how many people came to your party. All right, so I did all the work that I just talked about. Okay, we subtracted 100 first, right here. All right, then divide by 6, okay, and you should get 27. So that would mean that 27 people showed up to your party. I don't know how many you invited, but so you guys get the picture. All right, there's going to be a problem on your practice quiz, okay, that's just like that. All right, obviously a different story, different context, okay, but you're going to do it the same way. All right, so just like we've been solving these equations, okay, we've talked about this the last few days, kind of been hinting at it, okay, the next half of this chapter is going to be all about solving inequalities. Okay, so just like we solved that last equation, okay, that's an equation now. This is an inequality, sorry. Okay, and remember, the mouth always eats the bigger thing, so that means everything on the right, basically what this means is left is less than the right. Okay, so 100 plus 6x is less than 262. We always read it left to right, remember, and it eats the bigger number. All right, so solving these inequalities, okay, you do the same exact steps. All right, we subtract 100. But notice now, every time I rewrite it, I'm not going to put an equal sign because there was never an equal sign there. I'm just going to keep putting that less than sign. So now it's less than 162 instead of equal. Okay, we're still trying to solve it, so we're getting x by itself. We know it's going to be 27, but it's going to be x is less than 27. So that would be our answer. All right, so if you notice, to solve inequalities, you're doing the exact same steps you've always done to solve equations. It's just that instead of copying and pasting the equal sign every step, it's not an equation anymore, so there is no equal sign. It's a less than. Okay? Show you another one now, okay? So I'm going to make it a greater than now with an equal sign under it. Okay, it doesn't matter. 5 plus 4x is greater than or equal to, let's say, 13. Okay, so again, if we're trying to get x by itself, we're trying to solve these things. Subtract 5. And remember, the sign we're just copying and pasting. Greater than or equal to 13 minus 5, 8. All right, then we divide by 4. X greater than or equal to 2. Okay, so again, same steps. It's just whatever the sign is, greater than or equal to, we copy and paste that instead of the equal sign. And then at the end, okay, what that does to our answer is now instead of x just being the number 2, x is equal to 2, this is saying x can be greater than or equal to 2. So that means, like, if you think about a number line, okay, we had some problems like this. If you think about a number line, if 2, I'm just going to put 2 in the middle. If 2 was right here, remember it's an equal to, so it would be a closed dot. And then this is saying x is greater than 2. So all the numbers greater than 2 would be to the right. Right? It'd be like 2, 3, 4, 5. So on a number line, this is what this actually represents. Saying that x can be greater than or equal to 2 means it can be 2. So it can be right here on the dot. Or it can be anything to the right of the dot. So instead of x only being able to be one thing, like in equations, okay, with equations, x is only one thing, it's one number, it would be 2, that's it, nothing else. But with inequalities, x could be equal to 2 here, it could also be equal to anything that's greater than 2. So there's a lot of possibilities for inequalities. And this is actually how you graph them right here. This is how you would graph. This is literally, you're graphing right here every possibility, because we circled the 2, put a dot there, and then we drew an arrow pointing everything else to the right, going on forever. So that right there is literally every possible answer. So there's a lot of answers for inequalities. Same thing here, it's every possible answer. Alright, so that's the only real difference with inequalities, is that the answers are going to have a lot more possibilities. Okay, so one more thing I want to show you now. The only way these things get weird, and you should remember this from an assignment we did not too long ago. Make that a negative 2x. Okay, so again now, notice I put a negative. Okay, so we looked at all these things, and it was like they would ask you like, oh, multiply both sides by 5. Is it still true? Do this to both sides. Is it still true? Okay, and you should remember from that it was always true unless you divided or multiplied by, or divided by a negative. Divided or multiplied by a negative, sorry. All right, so let's go through solving this. Subtract 3, subtract 3. Okay, everything's fine. Negative 2x, copy and paste the sign, less than or equal to, then we'd have a 6. Okay, so now this is the only time that things get weird. Here our next step would be to divide by a negative 2. Divide by a negative 2. Okay, so it's still going to cancel. But remember, whenever we divide or multiply by a negative, the statement becomes false. So whenever you divide by a negative, what you have to do is you have to flip the sign around. Okay, so notice this was a less than or equal to. Okay, the problem started with less than or equal to. So we copy and paste, right? But as soon as we divide by a negative, as soon as you have to divide or multiply by a negative, the sign has to flip around. The sign has to flip around. Okay, if there was an underline, the underline stays. You don't have to worry about that. If there was no underline, then there would be no underline in the new one. But the sign has to flip, change directions. Okay, so that's something we're going to write down. That's something I need you guys to have in your notes. That's like the main idea with these inequalities, is when you solve them, okay, when you divide, I'm going to go real shorthand. When you divide or multiply by a negative, okay, we have to switch the sign. Switch the sign. Whoa, that's not how you spell switch. Switch the sign, okay? When you divide or multiply by a negative, the sign has to switch. Okay, and just a review of what that means real quick. If it was like this before, then it's going to switch to that. If it was like that before, then it's going to switch to that. Okay, same thing. If there's underlines, they still have underlines. If there's not underlines, they don't have underlines. All right, but the signs have to switch. So that's all you need to remember when solving inequalities. Same steps as everything else as equations, but switch the sign if you divide or multiply by a negative.